Well, still, okay, we're still waiting for another participant to join the Zoom meeting room, but we're going to proceed the activity. Okay, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay,
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
yeah, good morning, everyone. A very warm welcome to all participants joining us today. So it is truly a great pleasure to welcome you to today's seminar entitled Microalgae Biorefinery, Views in Upstream and Downstream Processing. Now, this event is hosted by Biology Study Program, Universitas Pendidikan Indonesia, as part of the Adjunct Professor Program, a series of academic activities featuring our distinguished guest, Dr. Kuan from Yonsei University, Taoyuan, Taiwan. And Dr. Khoo is a renowned researcher in algae bioseparation and has made a significant contribution to microalgae biorefinery studies with an impressive H index of 65. We are truly honored to have him share his expertise with us today. And today's seminar marks the first of three main activities in this Adjunct Professor series. And the second session will take place on November 7th with the theme Microalgae Biotechnology, the Shipping Artificial Intelligence-Driven and Prediction Models. And in that session, Professor Topik Hidayat will also join as a collaborator, presenting his topic about microalgae-based future tree. And the third activity will be held on November 14th, specially designed for lecturers within the Faculty of Mathematics and Natural Science, focusing on tips on writing a review article. Although we truly wish we could meet and share this moment in person, but due to several considerations, we believe that conducting the seminar online is most effective and practical way in this occasion. Okay, before we begin the activity, let me kindly remind all participants to few simple guidelines. The first one is please use the virtual background provided. Keep your camera on during the session, and please mute your microphone unless you are speaking. During the discussion session later, you are welcome to ask questions directly by turning on your microphones, or if you experience technical issues, you may also type your question in the chat box. Okay, to start our program, we will have the opening remarks first from the head of Biology Study Program. And after that, we will take a group photo. And after that, we proceed to the main session. So once again, thank you for joining us today. Now, without further ado, I would like to invite Dr. Wahyu Surakusumah MT to deliver the opening remarks. Please welcome Dr. Wahyu.
Oke, thank you, Bunda Dia. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. On behalf of program Biology Study Program, it is my great pleasure to welcome you all today. Webinar. We are truly honored to have Professor Ko with us, a distinguished expert in field of biotechnology and microalgae research. This session is valuable opportunity for us to gain new insight and broaden of our perspective on the latest development of biological science. We have today discussion will inspire further collaboration, innovation, and curiosity among us all. Nanti bagi mahasiswa yang ingin bertanya, silakan nanti bisa dalam bahasa Indonesia, nanti bisa dibantu oleh moderator, dan nanti kalau ada pertanyaan juga bisa dituliskan di dalam kolom chat. Thank you, Professor Ko, for sharing your time and expert with us. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Mr. Wahyu. And now we're going to have a group photo first. So maybe Mr. Khoo, I'm sorry, can you please stop your share screen first? Okay. Okay. I remind everyone to open your camera first. Okay. Please open your camera. And since we don't know our location, our exact location in this Zoom room, please keep smiling along this session, okay? Okay.
Mohon dibuka kameranya untuk difoto
Ya, silakan.
sebentar.
Silakan dinyalakan kameranya ya, teman-teman. Baik. Ya, baik. Sudah cukup banyak ya yang menyalakan kamera. Oke, Ibu Restu, are you ready to capture the moment?
Yeah.
Okay, start from the slide one. Okay, keep smiling. One, two, three. Okay. Okay. Second page. One, two, three. Okay, the third page. One, two, three. And the last one. One, two, three. Okay. What? Okay. Okay. Okay, thank you so much, everyone. Thank you, Ibu Restu. So now we're going to go to the main session, the presentation session. But before that, I'm going to read a bit about Mr. Khoo's CV. Okay, so our speaker today, Dr. Kuan is an assistant professor at the Department of Chemical Engineering and Material Science at Yonsei University, Taiwan. He is a leading researcher in microalgae biorefinery, focusing on both upstream and downstream processing, including cultivation, extraction, and purification of valuable bioactive compounds such as proteins, lipids, and carotenoids. Dr. Khoo obtained his bachelor degree in applied chemistry or sustainable chemistry from University Teknologi Petronas, Malaysia, and completed his PhD in chemical and environmental engineering at the University of Nottingham, Malaysia, impressively within just 2 years. So he didn't go to master class, but from bachelor proceed to PhD. His research integrates advanced extraction technologies such as liquid biphasic system and ionic liquids, along with IoT and artificial intelligence application in microalgae bioprocessing. He has published over 200 scientific papers with more than 10,000 citations and an age index of 65, and serves as an editor and reviewer for several international journals. Dr. Khoo has received numerous honors, including ICHIM-E Malaysia Young Researcher Award in 2022 and recognition as one of the top 2% world scientists by Stanford University in 2023 and 2024. He is also an adjunct professor at Chulalongkorn University, Thailand, and a visiting professor at several universities across Asia. So, wow, very amazing, right? Okay, without further ado, let's jump into our main session of presentation from Dr. Khoo about microalgae biorefinery, views in upstream and downstream processing. So please welcome Dr. Kuan Shiong Khoo.
Thank you so much, Miss Nadia, for the very kind introduction about myself. Also, thank you so much, Prof. Wayu, for having this opportunity to collaborate with the Faculty of Mathematics and also Natural Science educations. So, I think we have around 90 over participants here today, right? So that's a very big number that the support for my talk. So anyways, let me introduce about myself. My name is Guan Xiong. I'm currently an assistant prof in Yonsei University, and I'm just gonna share a little bit about microalgae biotech. So for those who have not looked into this research topic, I will be sharing what is actually microalgae and what is actually upstream and also downstream processing. Okay, so without further ado, we will start the sharing section right now by hold on. Okay, so Where is Yunzi University? Is a private university in Taiwan established by Far Eastern Group, and Far Eastern Group is like a group company that they have different kinds of businesses, and education is one of them. Okay, so currently we have 5 college that offers the bilingual program, and because under the leadership of our president, we are already having 10 to 15% of the international students, making it more internationalizations. All right. So we have President Liao, our current president right now, who's leading Yunzi University, and under his leadership, we can see that the ranking, the QS ranking based on the THE has already increased to 300 to 400 right now, right? So the group founder of Far Eastern Group is actually Mr. Shi Yujiang. So, and right now the son is the chairman, Douglas Tong, is under his leadership as well as for the Far Eastern Group. Okay, so when I mention about Far Eastern Group, education is just part of the sector. So they are also looking at construction, they are looking at transportation, hotels, retails, finance, telecoms. So these are all the companies that they are working on, right? And as I mentioned, for the 5 college, these are the 5 college. We have College of Engineers, College of Electricals and Communication Engineers. We have College of Informatics, College of Management, College of Humanities, and also Social Science. And for me, myself, I fall under the Department of Chemical Engineering and Material Science. You will be wondering why the chemical engineering will mix together with with material science. The reason is because Taiwan is the leading of the TSMC, the semiconductor industry. So that's the reason why they put material science as one of the main core into chemical engineering courses. Okay. So where is Taiwan? Where is Yunzi University? Is that is located in Taoyuan, somehow in the nearby the airport. As you can see from the airport, it's around 13 minutes to reach our campus. And then our campus is very accessible because we are just nearby the Neili train station. So it's around 13 minutes for you to walk to the train station, and you can get the train station. Once you reach the train station, you can take the train all the way to Taipei, which is around 15 to 16 minutes. So the accessibility in Yunzi University is very convenient. Okay. In terms of environment, like right now, November, December, it's a little bit cold. So we are moving into the winter season right now. And about Taoyuan, there is no much earthquake zone, although you can feel the earthquake sometimes, but it's not as severe as Yilan and also the Hualien, this side of Taiwan. Okay, and the language that they speak is more on Taiwanese, or we call it Hakka, and usually they use the traditional Chinese to communicate. Okay, and in terms of night market, Taiwan night market is opening every day, even on Monday. So it's a very hot place to visit as well. Okay. All right, so that is a little bit introduction about my campus. So we are coming back to today's topic, which is on microalgae, biotechnology, views in upstream and downstream processing. So basically, why are we still emphasizing research on microalgae? I believe the term microalgae here is already very common. And you can see that the word, perhaps let me change to the pen. The word here, micro, means microscopic, all right? Micro, microscopic, and then algae, basically they are known as plants. Okay, so basically microalgae, they are called as microscopic plants. All right, so moving on, why microalgae? Because first thing, they grow very fast compared to the terrestrial plants. Terrestrial plants, perhaps it will take 2 years, 3 years to grow to a very mature plant. But for microalgae, it only takes around 14 days or maybe 3 weeks for it to grow. Okay. So, Another thing about microalgae is that they contribute to the low carbon initiative because they are plants. They can absorb or assimilate, right, the CO2 from the environment and then use it for their growth. So this is a source of inorganic carbon that is being intake for the microalgae, right, for the Kevin cycle for the microalgae to grow. And then it's not just that, because they can grow, they will produce more biomass. The biomass can be used for fuel, can be used for feed, they can use for food. Okay. At the same time, microalgae, they bioremediate the wastewater. And because we know that the wastewater, they contains a lot of nutrients. Okay. So the nutrients such as nitrogen, they have phosphorus, potassiums in the forms of nitrate, phosphate, right? And also these kinds of ions, they can assimilate the nutrients and use for their own growth. So this is one of the way microalgae plays a role, right, for wastewater treatment system, because they have the components such as proteins, they have lipids, right? They have carbohydrates in their biomass. Therefore, they can convert all these compounds into value-added bioproducts, which I will be sharing later on in the downstream processing section. Okay. And because microalgae consists of lipid, therefore the lipid can undergo a process what we call transesterification, right? And this process will give us biofuels, and not just biofuel, undergoes like, or we call the photo fermentation. They will produce biohydrogen as well. This is a source of energy that is derived from the microalgae. They do not compete with the agriculture. At the same time, they can be cultivated under the high exposure of sunlight, meaning that especially in tropical countries like Malaysia or Indonesia, we have a lot of suns. So these microalgae love it so much, they can grow it without the worry of dying. Okay. And because their biomass can be growth on and on and on. Therefore, then it makes it renewable as compared to fossil fuel. Once you use it and that's it, we have to wait perhaps decades to have the fossil fuels again, right? But microalgae biomass, you can always replenish the biomass on and on and on. You just have to grow the microalgae. At the same time, I believe the algae industry right now is growing very rapidly, especially in Japan. There's a lot of companies growing just to sell the photobioreactor or just to sell the product of microalgae biomass. Okay. So as you can see, the word here, third generation biomass, they are known as third generation biomass, whereas the second generation is on the lignocellulose um, biomass, and the first generation is on the food derived biomass, right? So microalgae, they're known as third generation biomass. So somehow they are called alternative source for the renewable fuels, okay? Because they contain proteins, lipids, carbohydrates. Therefore, they serve as a potential feedstock that can be converted into biofuels, supplements, animal feeds, biofertilizers, and many more. Okay. And at the same time, we know that microalgae is actually a plant. So when we talk about plant, they will undergo a process which is photosynthesis process. They capture the UV from using their chloroplast. Therefore, they assimilate the carbon dioxide, undergoes the Kevin cycle. Therefore, this approach creates a low carbon initiative, making the environment much more greener. Okay, so this is somehow the benefits or what one should know about microalgae. Okay, so this is my lab in Yonsei University. Currently, I'm working on a few microalgae species. There is more than 30 to 50,000 species out there, but I'm only working on a few selected species. For example, here we have Hemacoccus pluralis microalgae. right? This microalgae is a little bit special because they will generate the astaxanthin, and astaxanthin is a highly antioxidant carotenoids, okay? So it will turns from green to red color, right? So another one is spirulina. I believe spirulina is already largely commercialized in the market. They already have the products which is edible as the what we call supplements, okay, because they consist of the C-facocyanin. All right, perhaps let me just write it down here so that everyone can see. Right, the first one is actually called astaxanthin. Okay, the second one for spirulina, it's what we call beta. Sorry, C-facocyanin. Okay, and this is a blue pigment, okay, a blue pigment, whereas astaxanthin is a red pigment, okay. So this is what carotenoids looks like, okay. And last but not least, I'm also cultivating Chlamydomonas rehatzi, and this is a very potential microalgae used for biofuel production because they consist of high lipid composition. And we also have Chlorella, which is a very strong species used for wastewater treatment, okay. So as I mentioned about this astaxanthin producing microalgae, which is Haemacoccus, this microalgae is a little bit special because it will turn green, right? Green color to red color. And the red color is what I mentioned, which is the astaxanthin, okay? The astaxanthin. And this carotenoid, this carotenoid is a highly antioxidant compound. All right, it means that it can remove the radical, right, very, very efficiently as compared to other types of carotenes. Okay, so how we astaxanthin, if it looks brown, it's actually not brown. It actually turns from green, right, green to red color pigment, and this is actually the red color pigments. Okay, so how it looks like when biomass is broken down, all other astaxanthin accumulated inside the biomass. Okay, so as for today's topic, we are talking about upstream and also downstream processing, right? So let's start with an overview, what is actually upstream and what is actually downstream, okay? So in the upstream section, we will focus more on the cultivation. So what does it mean by the word cultivation? It means growth, okay? Growth, or you can call this stage is producing biomass, meaning that we are trying to find an optimal or optimized condition, right, by altering the temperature, the light intensity, right, the pH condition, the aerations, the mediums, so that our microalgae will grow healthily. And this process will take around 7 to 14 days. If you read back the research paper, you will notice that some experiments will carry out within 7 days, some will carry out within 14 days. That depends on the species of the microalgae itself. Okay, so moving on, after we grow the microalgae, the second stage is where we biosynthesize. So what does it mean by biosynthesize? Meaning that we are trying to make the microalgae to produce the target biomolecules. Okay, so what types of biomolecules? For example, proteins, we have lipids, we have carbohydrates, perhaps carotenoids. Okay, so we are trying to target them to produce these specific molecules. So how do we do that? Okay, we can try to control the temperature, maybe giving them a stress condition. Okay, we can give them stress conditioning, or at the same time, we can do nutrients starvation, meaning that we don't give them the nutrients that they need. Therefore, this will trigger their mechanism to produce more lipid or perhaps more proteins. Okay. So after the biosynthesis process, we will go to a stage is what we call maturation. Maturation subject to the bioactive producing microalgae. So at this particular stage, one, they accumulate to a high biomass concentration, producing the high composition of, let's say, proteins, let's say lipids or carotenoids. Therefore, we can move to the downstream processing. So when we talk about downstream processing, downstream is where we want to obtain the value added products. Okay, we are trying to find a way how to harvest. You can see here the word here, harvesting, all right, or we call collection. We are trying to collect the biomass, okay, because we know that this biomass are very useful product. Okay, so how do we do that? We can do settling, centrifugation, right? Flotation method, right? So these are the method perhaps we can collect all the biomass, right? And we can use it to do the extraction. Okay. At the same time, because the microalgae is cultivated inside the water medium, therefore we need a drying process. The drying process is actually to remove the percentage of water content, okay, the water content inside the microalgae biomass. We try to remove as much water content so that we can preserve the biomass for later use. Okay. And last but not least is the extraction process. So once we have our biomass already, let's say that the biomass is a cell, therefore inside the biomass we have all the useful product. We want to break the cell wall so that the useful product can easily come out, and these are the product is what we call biomoly biomolecules, which is a useful product for us to use at the end of the day. Okay, so upstream focus on biomass quantity and also quality. All right, whereas the downstream focus on value added product. Okay, so let's start with upstream processing. We only want to focus on the biomass quantity and also the quality of the product. First thing, when we grow microalgae, we cannot just grow the microalgae in a very large scale with small cell density. We need to grow it from a small scale. Okay, so this is where how it looks like. From a small scale, let's say 250 mil. And then once it grow, let's say it takes 7 days to grow, then we can top up perhaps to 1 liter. Okay, so from 1 liter, we can let it to grow, and then once it reach an optimal density, okay, therefore we can transfer it to a 20 liter. So it's a step by step growing. It does not mean that I can use 250 mil directly jump to 50 liter. Okay, if you jump from this scale, therefore you will make the microalgae to die, because the microalgae will feel very surprised why suddenly I'm growing in such large environment. You will not feel comfortable. So this is not a right method to do it. You will need to grow it in a smaller scale all the way, increasing gradually all the way to a larger scale. So the way should be correct. Okay. So at the same time, when we grow the microalgae, we always use a method to measure the biomass. And the method is what we call optical density, or you can use the word absorbance. Okay, so where you can get this? You can get this using the UV vis spectrophotometer. Okay, so this is one of the equipment that we can actually measure the biomass concentration of the microalgae. Okay, at the same time, once we measure it, we can monitor the growth from day 1, day 2, day 3, day 4, day 5, all the way, right? And once it reach a stage, right, a maturation stage, okay, therefore they will start to die. Okay, they will start to decline all the way down here. Okay, so it's like a growth cycle depending on the microalgae species itself. Okay, so perhaps once we reach a certain time, all right, perhaps 14 days, therefore we can harvest. Okay, we can harvest the microalgae biomass and use it to do the extraction. Okay. And then you can see that the harvesting process, this is the wet biomass, meaning that the composition of water, okay, is very high. So of course, we need to dry the microalgae. We can use the freeze drying method. We can use the freeze drying method. At the same order, we can use the oven drying method. Okay, but that depends on what product are you targeting. But if you are using a product that is temperature sensitive, meaning that let's say the bioproduct cannot be more than 30 degrees Celsius or it will destroy. So we need to use the freeze drying method, because the freeze drying, it will dry at negative, perhaps negative 80 degrees C, which is a very low temperature method. Okay, but if we don't even mind about the composition, we can always go for oven drying. So oven drying is a very quick method. Perhaps if you dry it at 70 degrees Celsius, the biomass you have can easily remove the moisture content inside the biomass. And of course, we do the standard curve. The standard curve is one of the way for us to measure the biomass concentration. Okay, so you can see here, this is biomass concentration, and the unit is in gram per liter. Okay, so the absorbance, you can see from here, we can record it every day. All right, so this is how we do it, creating a standard curve. This is a standard curve. Perhaps the concentration is from 0.1 all the way to how much is it? 2.8. All right, so this is also one of the way we can do the quantification. Okay. At the same time, because we know that the microalgae contains a lot of the composition, we can also measure the absorbance, the wavelength, depending on what type of product we want, whether is it carotene, lutein, or other types of carotenoids. Okay. So I'm going to share with everyone to here today, it's how the photobioreactor being set up. This is a lab scale. Usually when we conduct the experiment, right, we will use 250, 500 ml or perhaps 1 liter to grow the microalgae. Because one thing we need to know is that we are doing optimization, okay? Optimization to grow and to see which condition serve the best condition for the microalgae to grow. Okay, so this is, you can see that this is the setup of how we grow our microalgae. Of course, we need to have the aeration air, right? We use the aeration pump, right? And this pump contains oxygen and also some CO2 composition that actually aerate the system of the microalgae. We do want the microalgae to stay stagnant at the bottom of the scott bottle. We want it to float around, consuming all the mediums that is required for the microalgae to grow. Okay, and of course, there is been some development that they put some different LED light. Okay, they put some different lights such as green light, red light, yellow light. Okay, they want to see whether this microalgae under the different um different wavelength. Okay, they want to check whether the microalgae under the different wavelength, whether the microalgae will grow efficiently or not. Okay, so that depends on the condition themselves. You can see here green, right? This is green, this is red, this is blue. Okay, so if we are talking about large scale production, right, we are moving out from the lab right now. So when we talk about large scale production, they will need to use a bag photobioreactor, as you can see from this. Okay, so you can see that how they can grow this, and this is how one of the project carried out by UPM under the leader Prof. Rapsi. Okay, they actually create some kinds of photobioreactor and use it to agitate the microalgae. All right. And we also have the design such as flat panel bioreactor. We also have the test tube photobioreactor. And this is the single tubular photobioreactor. Okay. So at the same time, in microalgae researcher, they are also looking into solid state inocular, meaning that we are trying to preserve the strain. All right. Instead of staying in the liquid state, we can also use solid state inoculation to preserve the strain. Okay. And this is one of the microalgae farm in Donghai University. Okay, so Donghai University is located near at Tainan, right? And this is where they use this kind of photobioreactor. This is around 200 liter. I think if this is around 500 liter photobioreactor. And they will have the aeration to push and agitate the whole system, as you can see from this setup, right? So what they use is that they use the waste nutrient, right, from the aquaponic system. The waste nutrient from the aquaponics system, all right? And this waste nutrient consists of the nitrate, right? The nitrate and also the phosphate compound. And these are what we call nitrogen source. Okay, and it's very useful for the growth of biomass. Okay, so at the same time, we previously we have a collaboration with Biolina, and this company is working in the spirulina cultivation. So they use the some of the nutrients to grow the spirulina microalgae, and this is one of the farm that we are working on, and it's a very big farm. They agitate the system using this kind of plastic photobioreactor system, open door photobioreactor system. At the same time, we also have visited Mr. Walid. Okay, so I call him the spirulina man because he's the he's commonly eat the spirulina as one of the protein source, right? And he use it to put into different kinds of food. Okay. But one thing when we grow microalgae in a large pond condition, you will notice that there will be some contamination. As you can see that the tadpoles, the frogs will jump into the cultivation system. They will start to produce their tadpoles into it, and the tadpoles start to grow, and you will see that this kind of tadpoles growing inside the microalgae. And just imagine if we are eating the spirulina biomass. So it will feel a little bit slimy because somehow the tadpoles has give birth into that system. Okay, and at the same time, because we are growing in the out pond condition, one thing you will see is the word here, contamination. Okay, So contamination takes place when the bacteria comes in. So the bacteria somehow will interact with your microalgae biomass, therefore creating this kind of biofilaments. And this is not what we want because somehow it will disrupt the ecosystem of the microalgae to produce naturally. Okay. So that is more on upstream processing. So I've shared with everyone what is the basic condition, how do you actually monitor the growth of microalgae, right? So how do we grow the microalgae in the lab scale, and how do we, grow the microalgae in the outdoor system, okay? So now we are moving to downstream processing. So when we talk about downstream processing, always remember the word value added products. And how do we want to do it? Is that we want to do extraction. Okay, so when we talk about extraction, the first thing we need to do is pre-treatment. Okay, pre-treatment, it means that we need to destroy the cell wall. Okay, the second step only comes with extraction, or somehow you will see the people use the word recovery. Okay, so somehow this kind of terms, they are always the similar, meaning that we are trying to obtain, okay, extraction, we are trying to obtain the biomolecules from microalgae biomass. All right, so this is the keyword that you need to take note of. So one of the technology that I explore is the liquid biphasic system, or we call it as aqueous two-phase system. This is one of the previous name they used, ATPS. Okay, the word ATPS. And this system uses two type of different liquid, and the liquid will eventually use for separation of the target biomolecule. So what they do is that they put in two kinds of liquid, two types of liquids, or we can call this solvent. Okay, so inside the system, because we have hydrophobic hydrophilic interaction, okay, hydrophobic, all right, we have hydrophilic interaction. This is non-polar. We have, this is polar system. Because having polar and also non-polar system, therefore it can create a interfacial layer. All right, so you can see this part is what we call a interfacial layer, meaning that it will separate, right, the system which is hydrophobic or hydrophilic system. It will separate them into two phase. So the first phase is what we call the top phase, and the bottom one we call this bottom, right, bottom phase. So usually the top phase is the recovery of target biomolecule. We can use it to extract the biomolecules from the microalgae. Okay, whereas the bottom phase is to recovery the impurities, meaning that somehow your microalgae may contain different kinds of composition like contaminants. Okay, somehow it will settle down at the bottom phase. Okay, so when we talk about liquids being used, so this is the term we use. All right, the type of liquid being used. Okay, for example, polymer, all right, alcohol, we have ionic liquid, deep eutectic solvent, surfactant, acetone nitrile, and sugar. So these are the kinds of liquids that you can combine together, right, to make it a liquid biphasic system. At the same time, the technology has been improve. They put in some integrated system, meaning that they put in ultrasound. Later, I will show you guys what is actually ultrasound. I will show you guys what is electropermeabilization. And lastly is the barber assisted technology. Okay, I have not done it for the microwave assisted. All right. So the first one is liquid biphasic flotation. So when we talk about the word flotation, it means addition of air system, or we can call this bubbling system. Okay, so you can see that this bubbling system, right, they will float up into the air, and this we use a compressed air pump to actually pump into the sinter disc glass. So the sinter disc glass looks something like this, right? So therefore this is a sintered disc. We pump the air, therefore passing through it will create a lot of bubbling. Okay, so these bubbles, they will actually capture the biomolecule on the surface active of the bubble and then recover all the bioactive molecule at the top phase. Okay, at the top phase. So this is one of the system where we use to speed up. We want to speed up the separation of biomolecules. So we use flotation method to do it. Okay. So this is how the system looks like. We array with the air. You can see that you have a lot of bubbles that is pushing microalgae biomass. You see, you can push all the astaxanthin, and all the astaxanthin are accumulated at the top of the top phase of the LBF system. Okay, so this is the process around 1 minute. You can see that the bubble is all separated at the system here. All right, so it's very clear that this system is a very potential to speed up the recovery of astaxanthin to the top phase system. So at the end of the day, you will see this is the first phase, this is the second phase, and the top phase is the astaxanthin. And this is the compound of how we can extract, right, the biomass, right, from it. Okay. So the second one, I like to call this the flash system. Okay, why do I call it the flash? Have you guys watched the movie Flash? I think this is a Marvel, right? A Marvel story. Why I call it a flash? Because I using the electric. It happened very, very fast. And the electric is just a sparkling in 1 millisecond. And we can extract we can permeate the microalgae cell wall. So you can see that this is the positive and this is the negative the conductor itself, okay, the positive and negative. So therefore this create a electric field system. Okay, so once it create an electric field system happening in a very quick second, 1 millisecond, right? So it creates pores. It creates pores on the cell wall. So once it creates the pore on the cell wall, the fucoxanthin, right, will leak out from the system. Okay, it will leak out from the system. And what happened is that the LBF system that I've mentioned earlier, the bubble will extract all the fucoxanthin out from the system very, very quickly. In just 5 minutes, we can do the extraction. Okay, so this is the way we use electropermeabilization using electric, right? So the second one that I mentioned about the integrated assisted system, which is using ultrasonic. So you can see that ultrasonic is a prop. So this prop will agitate at a very high intensity. It creates a vibrate. Perhaps the word is vibrate at high intensity. So once it vibrate at a very high intensity, it will create three mechanisms. The first mechanism is to produce the bubble. The bubble will combine together. Second, the bubble, once they combine, they will create a compression. Okay, the compression will reach a certain stage and the bubble will collapse. So the bubble will create some energy in the forms of temperature and in the forms of pressure. So this is what happened when ultrasonic is being used to extract or to pre-treat the biomass. Okay, so you can see that some of the studies to implement the ultrasonic technologies, you can see that this is before and this is AF after. Okay, you can see that before the microalgae cell, right? The microalgae cell is very smooth, right? You can actually see the cell wall of it. But when we use the ultrasonic system, therefore this will destroy the cell wall. So when it destroys, you can see that a single cell, therefore it creates all the rupture, it has been ruptured. Okay, the biomass has been ruptured. Therefore, all the astaxanthin can be extracted from the system. You can see that this is red color. After the pre-treatment, it becomes colorless. Okay, meaning that all the astaxanthin has been extracted from the system. Okay. So moving on, when we talk about downstream processing, because we are trying to extract the bioactive compound from the microalgae biomass, one of the way we can use is also ionic liquids. Okay, so what are ionic liquids? Ionic liquids are liquid mixtures that compose of cation and also anion. So if I would ask you whether sodium chloride Na plus Cl minus, are they ionic liquid? The answer is no, right? The answer is salt is not ionic liquid. The reason because salt is solid in room temperature. Okay, salt is solid in room temperature. Therefore, an ionic liquid needs to be liquid in room temperature. Okay, an ionic liquid needs to be liquid in room temperature. That makes it an ionic liquid. What makes ionic liquid so special? Because they are tunable, meaning that we can change the chemical properties. The second one, they have high thermal stability. They have no vapor or pressure volatility. At the same time, they have low melting point. Okay, so I did a review. Actually, ionic liquid is a very commercialized liquid out there. We have imidazolium, we have pyridinium, and this liquid has been used for biomass processing. Okay, so my study, one of the study that I've worked, I synthesized a CO2 based LQ carbamide ionic liquid. And this ionic liquid is very special because we can easily recover the ionic liquid and reuse for the next extraction step. Okay. So this is how we synthesize the ionic liquid. We just need the di-alkyl-amine and 1 mole of CO2. So you can see that CO2 is one of the inorganic carbon. Inorganic carbon that we can obtain from the atmosphere or the environment. Okay, but in this case, I'm only using the dry ice as the CO2 source. So I synthesize these two compound together, the admin and the CO2, I mix them, and then you have your CO2 based alkyl carbamate. So you can see that this is the positive, this is the negative, okay? This is the positive and this is the negative. So both this compound that I've synthesized is liquid in room temperature. So I use it for cell permeabilization studies. So it's the same thing. I use it to extract, so it creates a pore system. Okay, it creates a pore on the cell wall. Okay, and this is based on hydrogen bonding interaction. So hydrogen bonding interaction is a non-polar, is a non-covalent interaction. Right? So it interacts with the cell wall of the microalgae, this creating hole from the system. So this is where I test for the microscope studies. You can see that the microalgae cell has create hole from the system, right? It creates hole from the system. Therefore, the astaxanthin can easily be extracted from the system. At the same time, because ionic liquid, one thing we need to be concerned is the cost, right? The cost of ionic liquid. The cost of ionic liquid. So this ionic liquid that I've synthesized, it can be recycled, meaning that we can reuse for the next extraction system. Okay, so this is how the overall life cycle of this system. Okay. So you can see here, the next one we have is cell permeabilization. I think I've been using the term permeabilization. Cell, it means biomass, okay? Biomass that is protected or enveloped by a cell wall or cell membrane. So when we talk about the word permeabilization, it means that we are trying to create pore on the surface of the cell wall and also the cell membrane. So if we are able to create the hole, right, all these holes from the cell wall, therefore the bioactive compound, these are bioactive compound can be easily extract from the system. Okay. However, we do not destroy the microalgae biomass at the same time. So they will come to a point which is membrane recelling. And this is the reason why I'm emphasizing on cell permeabilization rather than cell disruption. Okay. So if you destroy the cell, your cell cannot be used for the next growing system. But if we are permeabilizing the cell, only creating hole from the cell wall, we can then reuse the biomass for the next purposes. Okay. So some of the extraction studies, as you can see here, because the Haemococcus has 3 layers of cell wall, right? We have the trilaminar sheet, secondary wall, and tertiary wall. We can use ionic liquid method to cell permeabilize the cell wall of it, therefore release, right, the astaxanthin from it. Okay, so when we talk about downstream processing at the same time, it's not just on extracting or pre-treatment of the cell. In the downstream processing, we are also talking about biochemical conversion. So what is actually biochemical conversion? Meaning that we are trying to produce as much product, right, for better use. For example, in this case, we have biophotolysis to produce biohydrogen, okay, to produce biohydrogen methods, or perhaps we can use dark fermentation. Dark fermentation. So dark fermentation at the same time is also a very good way to produce organic acid. Okay, organic acid. For example, alcohol or carboxylic acid. At the same time, fermentation is a very famous process, okay? Because fermentation, what it does is that it will break down all the complex carbohydrate based on the 1,4-glycosidic bond, right? Therefore, it will produce this kind of products such as acetone, bioethanol, biobutanol, okay? And then we have esterification to produce ester, transesterification to produce biodiesel, right? And then we have another, the last one, if we can produce biochar, if we can produce syngas and bio oil. And this is based on pyrolysis. Okay, so it's a very large spectrum of product you can get at the end of the day. It's not just getting the astaxanthin or the carotenoids, but at the same time, we can reuse each and every compartment of the microalgae biomass to produce this kind of different value-added products. Okay. So there's always question people asking, like, what happen if my microalgae is grow using the synthetic medium? So synthetic medium is like the BG11, or we have the Zarok medium, or you can use the food grade medium. Okay, so they always ask, like, what happen if we use synthetic medium, and what if we use the waste-based medium? Okay, the waste-based new medium, such as we can mention this, such as food waste. Okay, we can say, how about we use waste water? Okay, so a lot of question being asked about the hygiene, about the safety, the use of the microalgae biomass. Okay, so this is where I break into 3 compartments. So let's say that if you are using the synthetic medium, the food grade nutrients, then you can consider algae-based food, because we are looking something that is edible. When we talk about edible, the waste should not be included as a resource for us to eat. All right, as a human being, definitely we do not want to, have a contaminated food, or to add the food is being contaminated or grown by using contaminated waste. Okay, so therefore we always use synthetic medium, right? Synthetic medium for algae-based food. Okay, but if we are using waste nutrient, meaning that your microalgae is grown using wastewater, all right, or using the food wastewater, then the biomass can consider for algae-based energy or algae-based food. Okay, algae-based bioproduct. Okay, algae-based bioproduct. Okay, so this is more on waste nutrient, all right? Waste nutrient, right? So these are the category of how microalgae biomass, right, can either be a food, it can either be an energy, it can either be a source of product, okay, depending what is the end use of the biomass itself, all right? Okay. So just now I mentioned about my visit to Mr. Walid. So I actually call him the spirulina man. He has a farm in Malaysia and is very famous for producing the spirulina microalgae biomass. So basically, when I visited his farm, he gave me this algae banana shake, and I actually drink it. And one thing I noticed is that I do not feel that it's disgusting. I do not feel disgusting. It's only actually tastes like banana. All right, it tastes like banana without any slimy or fishy smell. All right, so I can accept that. But the second thing he gave me was a bread with algae paste. So what happened is that it tastes fishy, it tastes oily. So that raises my concern. How can I convince other to actually eat microalgae, right? Because we know that spirulina is a high source of proteins. We know that they have very high source of proteins, and we know that proteins are very good essential amino acid for building the cells in our body, right? So that raised concern that if we are trying to make algae as a source of food in the future, we need to address the concern regarding the texture, the taste of the algae biomass. All right. And the third one, this is where I get the powder from my Sakura program. One of the company, the algae company, they gave me the algae powder. So I forced my student, because that day we have the typhoon, right, in Taiwan. We cannot go out, and then most of the shops are closed. So we cook the instant noodle, and we put in the powder, and we ask the student to eat, right? So if you do not eat this instant noodle with the algae, therefore you cannot graduate. So this is what I told the student. Okay. But anyhow, just jokes aside, all right? And anyways, we also have these kinds of blending. We just put in the spirulina, we blend it with the spaghetti, okay? We blend it with spaghetti, and eventually this is a very nutritious meal because we know that spirulina contains high source of protein. So this is one of the way we can uh, up value, or we can call this value added food ingredient, okay, just by using a very simple biomass, which is spirulina, okay. So this is one of the visit. I visited Japan, and I know I mean, it's eye-opening for me to see how the algae researcher at Japan are actually working on, right? I actually visited the center, the collection center, and ES, all right, NIES Japan, and they actually have various tons of microalgae species, and they have a lot of postdoc, all right, working there just to supervise or just to maintain the microalgae strain. Okay. So as I mentioned, microalgae-based product is not just a normal one, but it's already naturally commercialized in the Japan. As you can see, we have the spirulina-based ice cream. We can get this easily from Family Mart. Okay, it's already right there, and this is a blue color ice cream. All right, a blue color ice cream. So how they get the blue color is from the C FICO sign in. So C for FICO sign in from where? From the spirulina microalgae. And of course, they have cookies, they have smoothies, right? Lactic acid, seaweed is a very common one. You see, seaweed wakaname. This is from macroalgae, algae, right? And then, of course, they create the supplements like lactic acid, right? They have source of chlorella proteins. You can see chlorella proteins, right? Microalgae for miso soup. At the same time, spirulina, right? Used as a superfood, right? So with that said, I also want to share with everyone here what I'm actually currently doing. So I'm working on food waste. I'm using food waste as a source nutrients to grow my microalgae. So this is where we collect the food waste from the food cafeteria. Okay, all the food waste, whether is it liquid or whether is it solid, we just combine them together, we blend them, and we do a acid hydrolysis. Of course, we do a acid hydrolysis so that the nutrients can convert into hydrolysis. So the hydrolysis is actually a waste nutrient because it contains a lot of carbon, it contains nitrogen, it contains phosphorus, and all these nutrients are very useful to grow the microalgae. Okay, so as I mentioned, this is the growth, and then this is the biomass we have. We do our extraction, okay, to check the lipid, to check the carbohydrate, to check the proteins. Okay, so this is one of the work that I'm working on with my student Aditya's. He's an Indonesian right now working with me. Right, so we do the separation of the food waste collected. Of course, we only use the liquid portion. Right now, I have a project to work on the solid portion, and the solid portion we will go for furnace pyrolysis, and then this is to create biochar, which is also a very useful compound for the biofertilizer. So the liquid portion, we will use it as a nutrients to grow microalgae. Okay, so this is how we upcycle each and every part of the food waste as a resource. And this is what I say, one man's trash is another man's treasure. Okay, so we are waste valorizing it in every different way. Okay, so at the same time, because we are able to do this method, therefore you can see that the growth of the biomass is actually 2 times, okay, 2 times higher compared to the one growth using BG11. This is a synthetic medium, right? So you can see that using the food waste medium, we can make the algae to grow much more efficient compared to the synthetic medium. No chemical cost is needed except for the pre-treatment cost, right? Therefore, we only use it to produce. So at the same time, all the biomass I encapsulate using the alginate and make it into a tiny beads. Okay, these are the beads, and it contains microalgae, and then we use it as a biofertilizer. Okay, so some of the work that I have worked on, and especially on food waste and microalgae, all right, these are some of the work that I've published, some of the reviews that I've published on how to use microalgae as potential food, right? As not as a potential food, as a way forward, right? Which is our waste valorization method. Okay. And I'm also upcycling food waste to produce lactic acid. And this is not just on microalgae. We are using lactobacillus. It's a very small project by one of my master students. We are producing lactic acid because we know that the lactic acid is a precursor for producing PLA, and this is a bioplastic. Okay, it's a very useful bioplastic. So this is where I use the food waste with the lactobacillus bacteria to produce the lactic acid. Okay, and not just that, I'm also working on the genetic engineering of spirulina microalgae for astaxanthin induction. So this is where I study the genetic engineer. How can I make spirulina? Okay, how to make spirulina to produce astaxanthin. Okay, and then how do I extract the gene from Haematococcus, right? And gene into spirulina to produce astaxanthin. Okay. And then I'm also working on encapsulation studies. So encapsulation studies where all the biomass I encapsulate them into the alginate beads. Okay, so you can see that these are the different kinds of concentration that we have. And what do we use? We use it for the food wastewater treatment system. So this is how the food wastewater treatment system looks like. So we use this kind of system to remove the pollutants from the wastewater system. All right. And then at the same time, I'm also working on spirulina as an alternative food production. So this is where we do the separation of spirulina biomass, you can see here. And with the spirulina that we have grown inside our lab, therefore we use it for bakery. We bake the muffins, and then this muffin contains spirulina in it. Okay, so this is one of the small projects that we are also work on. And currently I'm working on food waste with microalgae to produce biohydrogen production. So this is where we use microalgae as an inoculum with the food waste to produce biohydrogen production. Okay. And some of the studies, we are also working on microalgae-based fuel cell. So this is where we are trying to create bioelectricity, where we can cultivate microalgae. This is where we cultivate the microalgae. Right? And then at the same time, we treat this with the waste water. Okay, so it creating a fuel cell system, right? I think lastly is on the IoT system. So IoT system is because of the COVID pandemic, we are not able to do the lab. So why not we install the sensor and connect it in real time so that we can do the lab at home instead of going to the lab. Okay. So this is where the system, how it works. We put in a lot of sensor. You can see that all these are sensors. For example, temperature, we have the light intensity sensors, we have the water sensors, right? We also have the pH sensors. So what it does is that we connect it using an Arduino system. Therefore, we can actually monitor the sensors accordingly. Okay, and this is the Think, the ThinkSpeak website, the ThinkSpeak website, so it can monitor all the raw data or all the sensors that you put into your microalgae cultivation. Okay, it can give you the data right there. Okay, so you can see these are the kinds of data that we have, right? You can see the data, all that we have. So it's all produced by the IoT sensors. And let's say if you do not have a laptop with you, all right, on that day, you can always use your smartphone, right? You can use your smartphone. And then what you need to do is that you need to log in into the ThinkSpeak website. And then from the website, you can check each of the criteria, each of the parameters and the sensors that is being placed into the photobioreactor system. Okay. So I think this is the roadmap of the microalgae towards net zero emission. We start from algae-based biofuels where we use microalgae to produce biodiesel, bio-oil, bioethanol, right? Biohydrogen and also biogas at the same time, right? So once these algae biofuels, therefore there have already people exploring for algae-based products such as food, bioplastics, supplements, animal feeds, fertilizers, all right? So this is where we utilize it as a product. And of course, genetic engineering is one of the hot topic as well. They try to study the microalgae metabolism, okay? But that is not my expertise. Mine is more on optimizations and more towards the conversion processes, okay? So IR 4.0, they put in automation. They make sure that the algae system is grow in a smart automation. And then we have algae green cities. Algae green cities is where the microalgae are incorporated into the facades, buildings, right? For example, algae power buildings, algae power lamps, and transportation system. So this is where they build an algae green city. And then moving on, we have net zero emission, low carbon initiative. And this is where all the researchers are actually striving ahead. 2050, we want to achieve a net zero emission of carbon dioxide. Okay, so of course we need to take care of the waste management system, not just the waste management system. At the same time, we need to take care of a lot of agriculture production system because it generates a lot of waste and electrics inside their production plant. Okay, and last but not least is Industrial 5.0. What is actually Industrial 5.0? I believe everyone right now, the hot topic is on ChatGPT, right? Groups, all these kind of AI technologies out there. So microalgae have also tried to use AI, right? Which I will be sharing later on in on 7, right? This coming Friday, one of the slides I will share with everyone how does artificial intelligence serve a role in microalgae cultivation at the same time or to predict the type of microalgae. Okay, so we are using this kind of intelligent manufacturing technology. All right. With that said, I'm very thankful and beyond grateful with all the mentors that I have, the team from Malaysia and also my team from Taiwan and all my international collaborators, right? Without their support, I do not think that I might not reach a milestone to here today. I might not be the one who working on the research without their help as well. We need a team to move forward. If we are alone, we are not able to do so much of this kind of research output. But definitely, this is a very grateful opportunity to work with them and also to know them. Okay. So with that, I would like to say thank you again to the organizing team for the workshop, and also thank you to Prof. Yu for this opportunity to collaborating and also to share my research. With that, perhaps I would like to open the floor for any Q&A if you have any, so we can take this section to discuss among each other. All right. So thank you, everyone.
Okay, thank you so much, Mr. Kuan for your great presentation. So we already discussed about the characteristic of the microalgae, which is a fast-growing organism that can contribute to low carbon initiative. It can produce a biomass that can be used as fuel, food, and feed, and many more. And there are 4 specific species that are being used, specifically like Haemococcus pluvialis, Spirulina, Chlamydomonas, and Chlorella. And then we talk about the upstream and downstream processing, which in the upstream processing, it starts from culturing, biosynthesis, and maturation, while in the downstream processing, it starts from harvesting, drying, and extraction using LBF, electric, or ultrasonic and ionic liquids, and many more. Mr. Ko also shared his latest research, such as using food waste for algae nutrient to produce a biofertilizer, and do a gene editing to spirulina so it can produce astaxanthin, and then the encapsulated biomass into alginate beads to do a wastewater treatment, and then use food waste to produce biohydrogen, and also the IoT monitoring for algae culture. Okay. We already have some questions in the chat box, but before we proceed to the chat box, I want to give a chance for everyone to ask directly to Mr. Ko. Okay, we have Kansa here. You can introduce yourself first, and then you can proceed to your question.
Okay, thank you. Good morning, Mr. Khoo. Let me introduce myself first. My name is Kansanidia Jasmine. I'm a biology student at Education University of Indonesia. I really enjoyed your presentation and apologies, Mr. Khoo. I am having some camera trouble, so I'll need to stay off camera for this session. Mr. Khoo, I noticed that microalgae have potential in drug screening for antimicrobial, antiviral, and anti-cancer agents. Are there any specific species that have shown the most promising results in this area of drug dis discovery? Thank you.
Okay. I think your question is mentioning on the bioactive compound of to produce the antiviral and antimicrobial properties from the microalgae, right? You're asking my suggestion what species out there, right?
Sa?
Am I right? The type of algae that you're asking that are able to produce the antimicrobial activity and also the antibacterial activities, right? Basically, I can share some with you. It's on Chlorella, Cocomyza, Schistosomus, Dunelia, right? These are the types of common microalgae that can produce this kind of metabolites. But anyhow, as I mentioned, it must be properly screened, meaning that let's say if you're using Chlorella, you need to take note that not all Chlorella may have these kinds of metabolite. Maybe they will have a percentage of the metabolite, but not 100% of it, because we know that microalgae somehow the major components will still goes to proteins, lipids, and carbohydrates, and some will produce more on carotenoids. But in terms of antimicrobial activities, like you mentioned, antibacterial, antifungal, antiviral, so this kind of secondary metabolite might be a bit low compared to the primary metabolite. Okay, so I hope this answer your question. Okay.
Thank you very much for your amazing explanation, Mr. Khoo.
Thank you, Kansa, for your question. For the next one is, it has a lot of names: Rizky, Tristan, Revan, and who? Okay, uh, you can go to the question.
Okay.
Introduce yourself first.
Okay. Hello, sir. My name is Tristan from Biology Class D 2025. I want to ask from your experience, how small is the microalgae's failure tolerance during the processing into biomass or other products? Like, for example, if I mess up just 1 degree Celsius, will the product end up in a different quality, or will it just still be the same? Thank
This
you.
question is get from ChatGPT.
No, sir. I think it for myself. For real, for real.
Okay. Okay. All right. To actually answer your question, because the factor, especially temperature, pH, and let's just take for example pH. Okay, if the pH is lower than pH 7, the microalgae, for example, Chlorella, will not grow well. Okay, one thing, the microalgae, it will have an alkaline pH because of the bicarbonate system. So somehow the pH must achieve to at least 8 or perhaps 9, but that is only for one type of species, for example, like Chlorella. But if you are talking about acidogenic type of microalgae species, then therefore it can survive very strongly in acidic condition rather than an alkaline condition. And to your question about the temperature, yes, temperature, that depends, because when we talk about stressing the microalgae, for example, Haemococcus, if the temperature is not suitable for the microalgae to grow, somehow the microalgae may not grow that efficient compared to the optimal temperature, and it may not have the ability to synthesize the astaxanthin that it's required. All right. So same like human, if we are put in a very hot or very cold situation, our body will not feel comfortable. We will try to protect ourselves, perhaps to wear a heater or perhaps to wear something that is comfortable. So similarly applies to this kind of living organism. So I hope this answer your question.
Yeah, Tristan?
Yes, thank you very much, sir.
You're welcome.
Oh, okay. Is there anyone who want to ask directly? Okay. Okay, Farel? Eh, Farel?
All right. Uh, okay, let me introduce myself first. My name is Muhammad Farel Ganindra. You can call me Farel. Uh, I'm from class D of the biology major. Professor, thank you, Professor. What presentation that was. I am. It is really thought provoking. I have a few questions to ask. First of all, uh, it does about this microalgae research. Uh, is it a new research that appears a recent research that has been done, or is it actually done for like a long, long time? That's my first question. And the second is while you're on your lecture, I am kind of struggling I'm kind of struggling to understand the advantages of upstream and downstream what do you call it again? Techniques, let's say. Can you please reiterate it shortly and maybe explain a little bit on the advantages of each strategy? That's my questions.
Okay, thank you so much. To be honest, for your first question, microalgae research, I believe it's not just me who working on it. I work it since I was an undergraduate students, but basically that I focus on the growth and also use it for wastewater treatment system, specifically to see the 4C phenol. So it's like a alcohol removal system. Okay. And in terms of microalgae right now, it's really not a new topic anymore. So if we are looking into the microbes biological world, microalgae is a very general topic. Many people are working on it. And until today, we even have a journal, Algae Research, working and publishing about microalgae, not just to produce different kinds of bioproducts, but actually exploring various type of species as well, and also looking into the metabolites of how microalgae can produce different kind of secondary or primary metabolites. Okay. So that is based on your first question. It's not a new research right now. It's actually a very general and common one. It's just that many researchers are implementing different kind of strategy to study about microalgae. So regarding your second question, which is on your struggle on the upstream and downstream techniques, right? So perhaps let me put in layman term. What will you do if you want to grow a plant? You need a seed, right? You need a particular seed, right, to grow a plant. So when you are growing a plant, right, the growing process, you water the seed, right? You put some fertilizer on your plants. So that kind of growing process is what we call upstream processing, right? You're trying to find a way to grow your plant, okay? So moving on the downstream processing or downstream techniques, once your plant reach a mature plant, or maybe you have a tree, so your tree perhaps will produce apples or perhaps some of the fruits that you want. You will do harvesting, meaning that we are trying to collect. So the collecting part is what we call extraction. We are extracting the source that we want. So similar concept applies on the microalgae biorefinery. We grow our microalgae to get the biomass, and then we utilize the component of the microalgae at the later part, which is downstream processing. Okay, so I hope this will have a clearer picture for you to understand what is upstream and what is downstream. Okay.
Yeah. Actually, I was asking about the advantage of each processes. I kind of struggle to get uh, this advantage point there. But thank
Okay.
you for the explanation regardless. Any once again, is there does
Yeah.
every technique have its own advantages?
Basically, when we talk about cultivation, if you want to grow a plant, of course, you will find the best condition, right? So that is depending on the optimization. That depends on what kind of approach you want to do. You want to water the plant for 3 days, 3 times a day, or you want to fertilize it 1 week, or perhaps every 7 or every week. So that depends on the strategies. So in terms of advantages, I would say that in upstream, you will find a more optimized condition, the best condition for you to grow. Whereas the downstream, you want to make sure that you produce a lot of the compound, for example, your fruits. So you want to find a more efficient technique. Instead of collecting it one by one, can you use a method to collect everything at one time? So this is like different kind of approach, right? We need to have some trade-off as well. That approach is efficient, but it may not be cheap. It may be costly. So that really depends. So we need to play some trade-off from there. So hope you have a clearer answer for this. Okay.
All right, Professor, thank you for answering my questions.
No
Thank you.
worries.
Thank you.
Thank you.
Okay, thank you, Farel. I give a chance again to anyone who wants to ask directly to Mr. Khoo. Okay, if there's no one, we can move to the chat box. The first question in the chat box is from Professor Hertin. So the question is, what is the freshwater media for algae culturing?
Again, what is the
What is the
medium?
freshwater media for algae
Okay.
culturing?
Okay, I think the basic one to answer this is the conventional one that everyone use is the blue-green medium. Okay, the blue-green medium, or we call it the BG11 medium. Okay, some of them are also using Zarok medium, and some of them are also using F1 medium. Okay, so that depends on the type of microalgae that you are growing. Okay, so I hope that answer your question on freshwater medium. But if you are implementing some salt condition, so that is for saltwater type of microalgae. Okay.
Okay, thank you. The next question is from Dr. Wahyu. One of the
Mm.
problems in algae culture in open pond is contamination. What is the impact of contamination on algae populations and how to overcome it?
Yes, I think I really agree on the contamination, especially in open pond system. And what we do is that we put antibiotics. Okay, we put antibiotics to prevent the metabolites to produce inside the culture of the spirulina. So we noticed that we thought that the spirulina can remove the bacteria, but the problem is it will create some biofilms that actually binds the bacteria system. But anyhow, because the spirulina will have a very high alkaline pH, meaning that it's more than 9, okay, or around 9. So because of this high pH, it will try to kill off the bacteria, but that does not mean that it's not alkaline resistant bacteria will not be there. It will still be there. So somehow we still need to have some antibiotics to take away this kind of bacteria. Yeah. Yeah.
Okay, so using an antibiotics. Okay, the third question is still from Mr. Wahyu. To produce a bioactive compound from algae, we use a technique to change cell permeability. And can you please explain how to change the permeability and how to ensure that the desired compounds can be extracted without damaging the cell so that the algae can still continue to grow?
Okay, so this one I should explain in two part, right? Because I did this during my PhD studies, and I noticed that the reviewer mentioned about milking because I submitted a work about ultrasound and also the electric. Okay, and everyone has been working on destroying the cell. They don't even care about the cell. But we later on we know that okay, we can milk the cell. What does it mean by milking the cell? Meaning that we extract astaxanthin and the microalgae cell, we grow it again. But this way, somehow the microalgae may not survive, okay? Because we already destroy or tear some of the important compartment inside. For example, okay, if a human go and do some surgery, so somehow it might requires a very long time for them to recover. So similar concept applies back to this kind of microscopic plants. So I do not have the exact answer for this because for us, we are working on downstream processing. Our only objective is to extract the compound. We do not matter whether the cell is alive or not at the end of the day. But perhaps for other biologists, they would want to preserve the after extraction process. They want to make sure that the algae is alive. So it's a two different story. One wants to extract, one does not. Wants to extract, but at the same time keeps the cell alive. So yeah, I really do not have the exact answer for answering this. Yeah.
Okay,
Okay, thank you, Prof. Ko.
Thank you so much.
maybe in the next time we can do a collaboration to combining two objectives. Maybe,
Of
okay.
course.
Yeah. We can move to the next question from Abelia Rahma. How has microalgae research developed in Taiwan? Has it already been applied in industry or still mostly at the laboratory scale?
Actually, in Taiwan, is already quite established under the pioneer Professor Joshu Chang. He actually has a company that actually use the piggery wastewater to cultivate the microalgae system. And it's not just in the laboratory scale, it's already in the industrial scale to treat the wastewater system in the piggery system. Okay. But at the same time, I've also met a lot of researchers. They are using the microalgae to produce the face mask. So they take some of the bioactive compound and put into the face mask, and they commercialize the face mask itself. And not just on face mask, there is also supplements like spirulina and proteins out there that is being selling in the pharmacies. At the same time, there are also people working a lot on the design of photobioreactor. They want to make sure that the photobioreactor can efficiently produce the high biomass concentration. So I think microalgae research is not already developed only in Taiwan, but as well as other countries like in Malaysia. I'm not sure about Indonesia because I visited last summer. I have not seen any plants. Perhaps there is. But in Malaysia, in Taiwan, or in Japan, or in Thailand, especially Thailand, they are actually moving forward to grow spirulina in a very large pond system. So I would say microalgae research is definitely moving forward. It's depending who is the key stake players or the stakeholders who actually wanted to invest in this kind of business. Okay.
Okay, thank you very much. And the next one is from Hani Soliha. What is the cell disruption method that can effectively release intracellular compounds while maintaining product integrity and scalability?
Okay, what is the cell disruption method can effectively release intercellular compound, product integrity, and scalability? I would definitely, I will stick back to solvent extraction. Okay, I will stick back to solvent extraction because somehow the solvent is much more cheaper to synthesize a large batch of ionic liquid. Ionic liquids, perhaps they are novel solvents, they may be green, but however, in terms of cost, it's very expensive. But if we are trying to consider in a large scale, definitely the traditional way is a way to go. But perhaps we can integrate something like AI system. The AI system can eventually optimize the condition so that somehow, somewhere, this kind of process can be optimized more efficiently. Okay.
Okay, thank you very much. We have three last questions, but before that, I want to give a chance again for anyone who want to ask directly to Mr. Khoo. Is there anyone? Okay, Rezada, please.
Firstly, I want to apologize because my camera is not working. I'm currently working on my thesis about the using of microalgae as solid fuel in coal-fired power plant using an open pond system. One of the challenge is the large amount of land required to meet the demand of for microalgae as fuel, due its to relatively low growth rate. As we know, photobioreactors require a significant investment too. Is there any affordable technology that can resolve this issue? Thank you.
May I know your question is on the one of the challenge is
Low growth rate.
okay, low growth rate, and your question is what is the most efficient technology to grow and optimize biomass concentration, right?
Yes.
Okay, you may consider using plastic instead of using glass photobioreactor or the or the what we call that one, the kind of big plastic, uh, the plastic bioplastic, those kind of plastic bag. I think in India they are working on the kind of plastic bags to grow the microalgae. Yeah.
Okay, thank you, sir, for the answer.
Okay. Is there anyone who want to ask directly again? 3, 2, 1. Okay. Okay, we continue to the chat box. The next one is the question from Nur Fajriya. What the key factors to consider when selecting the optimal microalgae species to maximize co-product yields in biorefinery? And what innovative technologies are being developed to improve the environmental sustainability and cost effectiveness of downstream processing?
Okay, so the first question on the key factor that to do the optimization, I would say that is your medium. So you need to know what kind of medium that are using to fit the right type of species. If your species is not compatible to the medium, it will not grow efficiently. Second is the environmental factor. So environmental factor plays in a few roles. First is the light intensity. Second, pH. The third, the bubbling system, whether you feed your microalgae with the aeration pump or you feed it with the CO2. For example, Chlamydomonas microalgae, if we put aeration pump, it will not grow efficiently. If the aeration pump even have a little bit 5% of CO2, however, it will not grow as efficient to put in more CO2 concentration as compared to the high CO2 concentration. And your second question is on innovative technology being developed to improve environmental sustainability and low cost effective of downstream processing. If you want things to be innovative, there is no low cost. The thing will be expensive. This is very straightforward. Okay. So I don't know why they are emphasizing of cost effectiveness if you want the things to be innovative. Let's say, for example, iPhone, all right, Apple. the phone is very innovative, right? With the camera, those kind of processors. Is it cheap? It's not cheap. Everything comes with a price. So same things to microalgae technology. We need to change the way we think as well, right? If we are trying to make everyone wants to benefit at the end of the day, there's no talking about cost effectiveness if we are talking about profit. But definitely we can optimize. I would say the word optimize. Optimize perhaps a suitable concentration to do the extraction, a suitable condition for the extraction, then yes, you can talk about cost effectiveness. But if you talk about innovative technologies, I do not think innovative technologies will be cheap. Okay, anything that is green will not be cheap. Okay, hope I answered
Yes,
the question.
actually. Thank you, Mr. Khoo. The next question is from Muzayin Fatah Arifin. What health benefits are most commonly associated with microalgae in consumer products today?
What health benefits are commonly associated with microalgae in consumer products? I would say antioxidant. Okay, I believe there's a lot of cancer patients out there, and one of the factor that actually causes cancer is the radicals, right? The inflammatories and also the radicals that's being generated by the sun. As we know that we exposed to the sun mostly more than 2 to 3 hours a day, and the sun UV contains a lot of radicals, and these radicals needs to be get written off. So one of the way how to get rid of radical is by consuming antioxidant compounds. So what kind of antioxidant compounds? The first one, vitamin C. I think this is the very common one. We drink a lot of vitamin C from orange and everything, from oranges, like the very high content of vitamin C. The second one you can consider, which is to eat supplement. So what kind of supplements? Like carotenoids. That one I will share, the astaxanthin, right? So astaxanthin is a very high antioxidant capability. It can remove almost most of the radicals that is inside our body. Okay, so remember antioxidants, that is the benefits that is produced by the microalgae. So it's one of the product out there right now in the pharmacy.
Okay, thank you very much. The last question from Arika. When using wastewater as a nutrient source, how do you manage the issue of biological contaminants or heavy metal uptake that could make the biomass unsuitable for high-value product? And does this have a significant impact on upstream processing?
Okay. When we talk about wastewater, there are different kinds of wastewater. There are household wastewater, there are industrial wastewater, there are food wastewater. There are also, agricultural wastewater. So depending on what kind of source that you are using. So if you are using a wastewater that is not subjected to heavy metal, so we will call that as organic source of wastewater. When we talk about organic source of wastewater, organic means carbon, hydrogen, oxygen, nitrogen. These source are very useful for the growth of microalgae, which is commonly found in the synthetic medium. But if you are talking about heavy metal wastewater, heavy metal is also one of the cofactor that can actually boost the microalgae metabolite, but not all wastewater. If over uptake of the heavy metal, the microalgae will die. Okay. Of course, we do not want to have a high exposure of heavy metal to the microalgae biomass. We somehow need to control the heavy metal concentration if we will consider using heavy metal wastewater for the microalgae growth. Okay. And in terms of biomass suitability for high valuable products, as I mentioned, you're already using waste. You will not consider for food application. That you will consider perhaps for bioplastic, which is non-edible, right? You capture all the source into microalgae and make it into a bioplastic. So that is one of the way to go. Perhaps the second one, you can make it into biofuels. So nothing related to food that are considered suitable for the biomass to be upcycled. Okay, so somehow, somewhere, this depending what do you want to use at the end of the day? What application that you are emphasizing? Whether is it food, whether is it energy, or whether is it product? and then you can choose the type of wastewater that you will introduce for your microalgae. Okay.
Okay, thank you very much. Okay, I give a last chance for anyone who still wants to ask to Dr. Khoo here. 3, 2, 1. Okay, I assume you already got the idea and you don't have any other questions. But just like mentioned in this slide, if you still want to know more about Dr. Khoo research and want to know more about microalgae, you can visit his profile in this website. Yeah, as you can see in the picture, the quansiongco.com, or you can email him through quansiong.co@saturn.yzu.edu.tw. Okay, then, Dr. Khoo, do you still have maybe closing remarks from you?
Oh, you mean I need to give a closing remark?
Maybe if you want, maybe if you want
Okay,
to give
okay. Yeah.
something.
I would say that microalgae is actually a very interesting field, especially for biological students, because we are talking about life, and anything related to life is useful and is meaningful to everyone, not just only on the growth, but at of the life cycle of it. Okay. And one thing is that microalgae, because they can carry out photosynthesis, they are known as plants. Okay. So somehow there are some microscopic microorganism out there that keep our sustainable green. So I would say them they are planet lifesaver. They produce oxygen and try to replenish good to the environment. Okay. So with that, I hope for those who are interested to do the microalgae, perhaps can always look forward the opportunity to explore in this field. Okay. So with that, I hope to see everyone on the AI with the microalgae. That is much more interesting compared to the one that I've shared today. I think everyone wants to know about the recent technology AI. So perhaps the next sharing, I will share like how AI can be incorporated. All right. So thank you everyone for here to support the talk and also to support the workshop. I hope you have a takeaway and a lesson for your own experiment. Okay. So all the best to everyone.
Okay, thank you very much, Dr. Kuan Shiong. So, ladies and gentlemen, and all of the students, we have now come to the end of today's inspiring seminar. On behalf of Biology Study Program, I would like to express our deepest gratitude to Dr. Paul for sharing his valuable insights and experiences with us today. And your presentation has truly broadened our understanding and a lot of information that we can get. We would also like to thank all the participants for your active engagement and thoughtful questions during the discussion session. We hope the session has been meaningful and intellectually enriching for everyone. As mentioned earlier, today's event is a part of three-session Adjunct Professor series with Dr. Paul, and the second seminar will be held on November 7th, focusing on microalgae biotechnology. Just like mentioned before by Dr. Ko, it will be more interesting than today's session. So we hope that everyone here can come again in the next session in November 7th. Okay. And in the second session, Professor Topik Hidayat also will present the microalgae-based future tree, and the final session will take place on November 14th, decided for FMIPA lecturers with the theme tips on writing a review article. We warmly invite everyone to join and continue learning from this upcoming session. Although we conducted this event online, we sincerely hope that the knowledge and inspiration shared today will stay with us forever. Okay, once again, thank you very much, Dr. Ko, for your generosity and time. And thank you also to our Head of Study Program committee members and all participants for making this event a success one. Have a wonderful day, everyone, and stay inspired, stay curious, and see you in the next session. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Prof. Ko.
Waalaikumsalam. Thank you.
Thank you
Thank you,
so much.
everyone. Thank you,
everyone.
I have to
Professor.
rush. Okay.